register as that on your computer as a HID device. So they can be used for a keyboard or mouse emulator, and they can work for just like a general any games. Doesn't have to run in Unity. But if you are using Unity, then you can use the Arduino Uno, and the Arduino Uno can directly send commands and messages to Unity, and this is what we'll be focusing on in the workshop. Oh, okay. Anyways, yeah. So I'll talk a little bit about, like, briefly before we start, like, using Unity. If you do want to use Arduino Micro, there is a library called keyboard.h, and if you just search that up on the internet, you'll find a lot of resources for it. And then you can get just like a general game controller working if you don't want to use Unity, or if you just want to make a general input device like macros or just something else that works with a computer. All right, but we are focusing today on using the Arduino with the Unity game engine. So in order to communicate with it, we're using something called the serial port that's on the Arduino, and it basically just lets us have two-way communications between the Arduino and Unity. So obviously, if you haven't downloaded the IDE, install it. But I'm assuming everyone has it. All right, so we can actually, if you guys want to grab like maybe a joystick or something like that. Well, I know we have a lot more joysticks. We'll probably use that for the demo. So yeah, you can go to the table over there and just grab one. Yeah. I can get that out. I don't know how you're gonna get it. I'm just gonna put it on the screen. No, that's fine. All right, we're gonna get started in a few minutes once everyone's back at their stations. All right, we're gonna get started again. So I've taken off the the joystick part off my joystick just so that you guys can see what I'm doing with the pins. But you guys don't have to take this off if you don't want. All right, so this is the joystick. You'll see there's 5 pins on it. Ground, 5 volts, one for the x-axis and one for the y-axis, and then the switch, because this one, if you click down, it does have a clicky button. So what you need is a I'm using a male to female cable, and I'm just going to connect all the wires to the header pin on the joystick. So yeah, you just want to make sure the cables are pushed in so you have a good connection. All right. So the first thing we're going to plug in is ground. So ground goes to ground, and then 5 volts goes to 5 volts on the Arduino. That's pretty straightforward. And this will provide power to the joystick. All right. So once you have the power plugged in, we're gonna plug the x-axis. So it says VRX and VRY. We're gonna plug those 2 pins into the Arduino pins that have like the letter A in front of them. So these are analog pins because this sensor uses analog signals to communicate with the Arduino. If you are having difficulties, or if you're not sure about something, you can raise your hand and we can have a mentor come and help you. And the last connection, we're just gonna put directly to one of like the numbered pins. I'm just gonna pick pin number 8. You can pick any other pin. So I'll give you guys a few minutes to get your joystick set up. If you want to get a better video, I guess you can come up and look at the setup, or you can raise your hand and come around and help. Yeah. I was giving some people some more time. All right, we're gonna get started again. So yeah, I'm assuming everyone has it connected now. We're now gonna go to the Arduino IDE. So, and we're gonna create a new project by going to File and New Sketch. Yep. So File, New Sketch should open a new window. And once the Arduino IDE loads, we're gonna save this as a project. I'm just gonna call it a game controller. Yeah, that's right. You need to plug it into the computer. You have the IDE? Oh, yeah, you need to take it. The VOD is always on. All right, so in the Arduino IDE, the first line of code we're gonna do is pin mode. And what the pin mode function does, as just a reminder, if you don't know, it's basically tells the Arduino what's connected. So since we have two axes on the joystick, uh, each of them is connected to either A0 or A1. We're gonna first do A0, and then that's an input device. So we're gonna put all caps input as the second argument. We're gonna do the same for A1, which is the other axis of our joystick. And that'll be A1, also an input device. All right, so once we have this, in order to get sort of see what values the joysticks is outputting, we gotta have the serial monitor open. So we gotta start with we gotta include the line serial.begin, and we're just gonna specify the speed, the communication speed at 9,600. It's an arbitrary number. You don't really need to know why, for the most part, but yeah, just make sure you have that number as argument. And in the forever loop, so in the void loop, we're going to basically read and output so that we can see the values. So to read, we're going to use analog, analog, can't spell, analog read, and you just specify the pin. So one of them is A1. So this actually returns a value. So we're going to create an int. I'm going to call it, I think this might be the x-axis, so I'll call it x. And then we'll just have it assigned to whatever the analog read returns. We're gonna do the same thing for the y-axis. So we're gonna create an integer y, analog read, and this time it'll be from A0 or whatever pin it's connected to. All right, so now we're gonna print out the output of the joystick. So we're gonna get a serial print ln, and the first value we're gonna print out is the x, and then we're gonna do another serial dot print ln, and we're gonna print out the y. And to end it off, we're gonna have a delay. So we're gonna put the delay so that it's sort of like checking the sensor every 50 milliseconds or so. I think that might be fast enough for now. So once you have all your lines of code, you can press verify to compile and make sure there's no errors. And then you can make sure that you have the right board selected by going to Tools, Board, and you should see that either Arduino Uno or Arduino Micro or whatever microcontroller you're using is selected. And you want to make sure that your serial port is connected to serial port. Should be here. That's weird. And then you can upload it and oh, I don't have my Arduino plugged in. But yeah, so once you have the code, you can upload it and you can go to the serial monitor icon, which is just like a magnifying glass. Oh, yeah, let's try that again. But yeah, the serial monitor is on the top right. If you open that by clicking on the magnifying glass, you'll see a console that opens. And I guess once it finishes uploading, we can see what it outputs. All right, so once you have it uploaded, you should see sort of when you open the serial monitor. On my screen, you can see it. It's at the bottom, and you should see a bunch of values. And when you move the joysticks, it should change a bit, right? So this is basically how the joystick works. It goes from like 1,000 to like 0. So one of the numbers is the x-axis, one of them is the y-axis. And yeah, so raise your hand if you're having issues, and I'll come around and help. All right, so yeah, I'll give you guys a few more minutes to get this working if you don't have it working already. After this, we're basically done with the Arduino now. We got values coming out of the serial monitor, and I'm gonna hand it over to Max, and he's gonna tell you how to integrate it with Unity. So you do have to have Unity installed, I guess. So if you don't have Unity installed, I guess you can try installing it now. Hopefully, it'll install in time. But yeah, that's the next part. So if you do want to open up Unity and start a new project, that'd be great. All right, yo, Max. Up. I can give you this, or already has the script. Like it's just outputting the numbers. Is that good enough? Okay, then change it here and then upload it, and then just have Unity on your end, right? The main thing is it's installed. The ID. All right, yeah. So Max, you want to do it here? All right, so we're gonna make a modification to the code, just so that to get it ready for Unity to read. Max is gonna do that.
All right, what is up? If you guys weren't at the workshop last night, my name's Max. I'm the U Ottawa Game Dev Club's president. And yeah, so we're gonna be making a little change in our script just so Unity can read it a little easier. So instead of using serial.println here to print the x and y values of the joystick on different lines, we're going to just print them on the same line. I hope this will work. We are just going to do serial.println x plus a space and then plus the y value. So if we save that and upload that to our board, let us check out the serial monitor again. Okay, hold on a second. It's not supposed to happen. Do give me a moment.
Okay. Use sprintf. Sprintf, and you pass in. You just use whatever function you want to use. Actually, what do you use for that? For that, you only have one value. Okay. Okay, so in that case, you can just say we're only going to print one value. And just only one active. Oh, yeah. All right, so you actually cannot concatenate strings like you would in any other language in C. So we're going to use a function called sprintf. So also strings don't exist. They're fake. Fake news. In C, they don't exist. In C, what strings are is basically just an array of characters. So to concatenate anything, you're technically just adding more stuff to an array. So, oh my god, it's frozen. What did this click? Yep. So if you look at the screen, the function we're going to use is called sprintf. And that takes a string, or like a character array that is the string, and then like some formatting stuff. So an example of this looks like this. So you'll max. No, I don't think so. Yeah, and then you concatenate the string, and then you print it. Wait, sprint? Yeah. Yeah. So how sprintf works is the first array is the string that like the destination of where the string should be saved. Then you have like, if you've used printf in C before, this might look familiar. You sort of have the string with like %f or %d for whatever value you want to add to the string, and then followed by the arguments that should be replaced by those these oh, I forgot what they're called, but these special characters, I guess. So it might be a little confusing, so in this case, just follow along. We're going to create a character array. We're going to call it Unity string. And we're going to give that a size of, let's say 25. It's not going to be a very long string. And then we're going to do sprintf. So the first thing we're going to pass in is Unity string. So that's the pointer to the array that we have. And then we're going to pass basically how we want to format the string. So Max, how did you want to format the string? You just want a space between the two? Yeah. All right. So the first, we basically just want like the x value, space, and then the y value. So we're going to percent sign d, space, and another percent sign d. And then we're going to add a new line character just so that it's easy to read. And then we're going to pass the x and y axis variables through. And we're going to end it off with a semicolon. So your string will be saved in Unity string, so we can just print Unity string. And then you can upload this and try it out. So yeah, you should see the x value, space, and then the y value, and like when you move the things, they change as well. So now that we have the code, we're going to be switching over to another laptop with Unity. So this is when you should open Unity. I'm just going to have the code up for like a few more seconds so you guys can, like, I guess, finish up typing if you need to. But if you need to see the code, my laptop will be here, so you can come up and take a look. But yeah, we're switching laptops now.
You know what? What are you looking at? Okay.
Google stuff or? Yeah, for now.
All right. So yeah, just give me one moment. So, huh. All right, so we're going to be using the same Arduino board that we were just using before. Um, the oh man, I'm going to be creating a new Unity project, and while that, well, I guess while Unity loads, basically, we're going to be using a open source library called Ardity to communicate between Arduino and Unity on the COM ports. Hello? Hello? Yeah? Alright, so yeah, just search Ardity on Google. It should come up here as the first result. Ardity.dwilches.com. Arduino plus Unity over COM ports. And this site, basically, it provides a download link for the Unity package. You can download that if you've got Unity already open. It's basically a Unity package file. We're going to want to show that in whatever folder it downloaded in. Make sure we have a project open, which I will be making one very quickly. Let's make it two-dimensional. Let's just call it Arduino demo project. You can call it whatever you want. And we will need to wait a little while for that to open. So yeah, basically, this library, you can read serial input through a built-in C# library in Unity. So you technically don't need to download anything except this library, Ardity, is really nice because it handles all the like threading, and it makes sure that you are getting the messages from your Arduino like at the exact time that they are being sent from the Arduino, rather than if you were to use C#'s built-in serial port library yourself, then you would have to take into account like timeout and baud rate and timing and everything and threading. So it basically just makes everything a whole lot simpler and like thread safer. Make sure there's no memory leaks or anything, and it's just super simple. So it has my personal seal of approval. The website actually also has a fantastic little, if slightly outdated, very comprehensive tutorial as to how to use it. But I'll be going through it in a moment. Yep, what's up? Oh. That's okay. I'm waiting for the project to load. So yeah, we're just waiting for our new project to load here before we proceed. It can take a little while. Yeah, like I mentioned, the instructions here on the site are a little bit out of date. The library still works perfectly, but there are a couple things that are different that you need to do in order to make it work. I presume we'll be sharing the slide deck for this presentation afterwards, and that includes some up-to-date instructions on how to get it working properly. It's taking a while. This is taking longer than it usually does, which is saying something. Oh. Okay. Our project is open. Not sure if anybody's following along, but I'll just give a little demo on how to get the connection up and running between Arduino and Unity now. So if you haven't installed, or sorry, if you haven't downloaded already, the Unity package file from Arduino, you're going to want to click this big button up on the top of their site. Find where you downloaded that Unity package file, and then open up your Unity project. We can full screen that. Go back to that folder and downloads, and simply grab the package file and drag it into the editor window anywhere. That's something really cool. Actually, wait. Oh, I guess it's got to be in the assets folder. That's something really cool about Unity is when you want to install a package, you can just download the package file and just drag it into your editor. And you'll see that the import Unity package dialog comes up. We're just going to import everything. All right. So the Arduino package is imported. We could check out the, it comes with some sample scenes that are basically completely already set up for Arduino input accepting, but we're going to make a new scene from scratch. Basically, the first thing we're going to need to do is create an object to read the serial data from the Arduino. Let's just call that our serial controller. And we're going to want to add to it a component here in the inspector that's from the Arduino package called serial controller. Wait a second. Okay, wait. I've gotten ahead of myself. The first thing we need to do, you'll see in the console, we have a bunch of errors. You'll see that we actually are missing, apparently, a typer namespace serial port. And this is actually the library that is built into C# that we can use. Actually, it's not built into C#, actually. It comes with .NET Framework. And the reason that Unity is not finding it is because we have to change some settings in our project. So we're going to go to Edit, and then all the way down here to Project Settings. We're going to need to change something in order to make that library accessible to our code. So in our project settings, we're going to want to go down to Player, and then scroll all the way down to, oh, wait a second. There are a lot of settings under Player, so it can get a bit tough. We want to go under Other Settings, and then scroll down until we find, or there it is, API compatibility level. So that's project settings, player settings, other settings, and then API compatibility level. We want to change that from .NET Standard to .NET Framework. Now this is something, if we check the Arduino site at the bottom, they will notify you of this error, and they will tell you that you need to change the API compatibility level to .NET 2.0 subset, which is not what the option is anymore. It's a pretty old version of Unity that this package must have been made with, but it still functions on modern versions, thank goodness. So if we go back to our, okay, it's loading. All right, back to our editor. You'll see that the errors for the serial port library are gone. We can just clear the rest of these. And we can go back to our serial controller, that object we created, go and highlight it in the hierarchy here, go over and add the component serial controller. You'll see it suggested right here if we search it. search bar. And the serial controller script provided by Ardity, it comes with the baud rate, the port name, and then some other variables. What we're most concerned about is we need the port name to match the port that our Arduino is communicating to. So we can check. I have the Arduino IDE open right here, and we can just check. All right, so there is a board communicating with COM port 4. So that's the one that we're going to want to put in that whoops, in that port name box. We're going to change that to COM 4. Now, of course, nothing is actually going to happen because we have not set up an object to receive the messages, because the serial controller script here only reads the messages. So we're going to create another object. Let's just call it our serial reader. And then we're going to want to add a script to it. It could be any script you want. Like you could create a specific script just to read the values. I'm just going to create one called serial reader here. Create and add this new script. Or you could just do it in, if you have like a game manager script or like a player controller script already, you can just add some methods to it. It's really simple. We can hit the little 3 dots here to edit that script we just created. And along with the start and update methods, we're just going to want to create 2 methods called, well, let's check the site. Alright, so we need 2 methods, one called onMessageArrived with a string parameter, and onConnectionEvent with a bool parameter. And these are essentially called by the serial controller script. OnConnectionEvent is called when the library successfully connects to your Arduino device. So you can tell in the game whether it's actually connected yet. And onMessageArrived will be called whenever a message is sent from the board to the serial port. And then that message will be provided as a variable in the string variable there. So we're just going to want to add those methods. Public void on message arrived string string message. And what we'll do right now is we'll just print that message. And Unity, you can use debug.log to print that message out. And remember, we also need public void on connection event with a Boolean parameter. Let me just double check to make sure I got that right. Yep. And we'll just print if success. So if we've successfully connected, then let's print successfully connected. And otherwise, if it was a failed connection, let's say failed to connect. And this is all we need on our message receiving object. And yeah, basically these 2 methods, you can add them to any script you want, as long as they are of this form exactly. We can now go back to our editor. Once it reloads the script, and go to our serial controller. And now we can grab that serial reader object we made and then drag and drop it into the message listener field on the serial controller object, so it knows which object to send the messages to. And now, that's basically all the setup we need. It's as simple as that. If we hit play mode now, we should, if you keep an eye on the console here, we should see successfully connected, and then whoa, look at all those numbers. Now if I mess around with the joystick here, you'll see that it is indeed changing. Alright. And there we go. We have input. You can do this with, yeah, it doesn't really matter, like any of the sensors. You can use this to get their input in Unity. Just make sure you're using the serial.print method in Arduino. Make sure you're capturing that serial input in Unity. And now we can use this in our game. For example, just for an example, I will make a little cube that we can control. You know, want a little bit of a joystick demo. Now, of course, in your game, you're probably going to want to make something a little more interesting than a cube to control if you're using a joystick. But you know, it's just to prove the principle of the thing. This cube will be our player. Okay, we'll add our player. And let's actually this serial reader script. Let's delete this object because we want the player controller to be reading our messages. So let's add a new script to our player. Let's call it player controller. And once it loads, we can edit it. And let's just go back to serial reader, that script we just wrote, and copy and paste those two methods. Put them in our player controller. But instead of simply printing the messages that are incoming to the console, let's capture them in a couple variables. Let's declare up here at the top, private float joystick X, joystick Y, and when we get a message arrived, we can get a a string array, and then split that message by space, space, because remember we put one space between the two values, and yeah, that's why we need to put them all on the same line, because otherwise we'd have no way of telling which was the X and which was the Y value. So putting them on the same line and separating with a space allows us to separate them like that and get them each individually. We're going to want to set joystick X to float dot okay, I don't exactly remember the method. I'm actually going to close this really quick because I did just realize that Unity defaulted to Visual Studio Code, which when it comes to Unity, I'm more of a Visual Studio, just period, Visual Studio kind of guy. So I'm going to go back to my project settings and go to my well, I have to give me a second to find the setting here. It's edit preferences, and then external tools. I'm going to change my script editor to Visual Studio. And let's open the player controller script back up again in our editor of choice this time. Alright, that is much better. Oh. There we go. So, we're going to set our joystick X to I forgot to set name for this string array. Let's just call it message array. Let us do float.parse, which will change the string value here from message array 0. That will convert that into a float that we can capture in our joystick X variable. And let's copy that and paste it, except change it to joystick Y this time, and get the first value instead of the 0th. And now we have stored as variables the values that our joystick is inputting on any given frame. So why don't we, in update, why don't we actually move our player according to those values? Let's get a move speed variable that will, just handle the relative speed at which the incoming joystick values are scaled. So public float move speed, and I'm just going to set it to 5 by default. So in our update function, we can simply increment our transform dot position by a new vector 3, which the x component of which will be joystick x times our move speed times time.delta time, which will make sure that the movement is equivalent across different frame rates. Now for our y, we're just going to want to do the same thing. Joystick y times move speed times time.delta time, and the z value will be 0. So this should work, save for any unforeseen well, actually, we may have to correct for the joystick's base value, because I think it's like 512 when it's in the middle. Anyway, let's actually keep the oh no, we still have the debug.log message. That's good. Let's go back to our editor, and I seem to have left out a semicolon. I did. Let's put that in. And well, let's see what happens when we I do realize I added a cube, and this is a 2D template, so I'm actually going to add a square instead. I'm going to right click, add a 2D object, a sprite, and a square. And let's get that player controller script that we made and add it back onto our new player. So if we go into play mode, all right. Queue phone dropping message. Oh, see what I've forgotten to do is in our serial controller, I've forgotten to reset the message listener object to our new player. And also I am seeing now that the default joystick values are 511 and 525. So, I guess what we're going to want to do is store some variables for those, and then correct for those as the middle value of the joysticks. Because if we were to go into play mode with leaving that as it is, then the cube would fly right off the screen without us even touching the joystick. We're going to want to set some public floats, default joystick X, and that was 511 if I believe, if I am correct, and then default joystick Y, which was 525. And now, just whenever we want to set our joystick X and joystick Y, we can get the value and simply subtract the default joystick X and a default joystick Y. And that will properly scale our value from like some negative 500 to like 500 instead of 0 to 1,000. So I'm going. Anyways, let's test it out. There's our cube. What happens when we... Oh, oh, oh. Joystick is very delicate. Okay, well, it does not seem to exactly be working. Hmm. Sorry, I'm just observing the input here so that we can properly correct for it. I think it should be functional. We have in our player, we have the default values, 311, 325, or 511, 525. The cube is inching around. We might want to decrease the movement speed a little bit there. Now, if you were making, a real game with this kind of functionality, you'd want to add some kind of threshold for the movement of your joystick before you want to actually count it as real movement, because right now I'm not touching the joystick, they're just little idle fluctuations in the values from the circuit, and you can see our cube is kind of shifting off the screen there. Let's see what happens if we move his move speed way down, and then see what happens if we... Alright, so it's not exactly working still. Let's just go check our script here to make sure everything is as it should be. Float.parse. Why don't we do some good old print debugging to check our joystick values. So every time we print out the Arduino input, we'll also print out what our current joystick values are, which they should be between negative 500 and 500 roughly. So let's check that out. Well, yeah, it does seem to be mapping correctly. Positive, negative. Alright, I am noticing that when we move the joystick to the left, the X value becomes positive rather than negative. So we can go ahead and apply that negatively. Yeah. So we're going to go over to our move speed and apply the negative of the joystick X movement. But otherwise, let's see if I haven't messed something up here. We got minus joystick X times move speed times time dot delta time. Joystick X times move speed times time dot delta time. That's our X and Y, and then the Z value is 0. This is curious. Let's try putting our player's move speed. Oh, wait, well first let's try. Oh. Let's set the player's move speed to 1. And... okay, well that did work. I think we're going to want to set the move speed even a little lower, because it appears our cube is still flying all over the place. Alright, let's give it one more try. Let's change the move speed. Let's put it down all the way to like 0.05. Because it does make sense, because the joystick values, like, like 500, negative 500, are pretty huge multipliers for move speed, so you're going to want a pretty tiny value to offset them. So there we go. Let me just secure the joystick with one of my hands so that I can mess around with it with the other. Look at that, we have joystick movement functionality. Woo! Thank you all. Thank you very much. And yeah, so that's how you can get your Arduino serial board output, bring it into Unity, and then apply it to create actual game controls. Isn't that cool? All right. Well, I guess that's the end of my bit. Thank you all for listening. Oh yeah, I did. Oh wait, here I'll mess around with it. Oh my god, come on. Workshop over. All right. Thank you all for attending. The workshop is now over. Thank you.